My name is İrem İlayda, and today I will be showing you my game called Seismic Escape. First, I will explain the project structure and code architecture. Then I will show you a live demo of the game. And let's start project structure. The project is built on a 3D point.js and plus white combination. Why this do? A 3D.js is a library that abstract a WebGL, making it possible to create 3D scenes in the browser. And white, on the other hand, is a modern build tool. It provides instant hot reload with ES module support, and we can get a production build with a single command using npm run build. If you look at the package.json file, and 3D version is here. This a basic 3D engine, and white this here, and development environment, and type is here, a model. Each file runs as an ES model. The source code is divided into two folders under this. First one is entities, world and player objects, and the other one systems and physics, gas system, gas simulation, and particles simulation. And I deliberate made this separation. Each system is in its own file and independent of each other. Let's main look. The center of everything is main.js. Here is a classic 3D.js setup. First, the renderer is created. I take the WebGL renderer, set the pixel radio, and enable the shadow map, and line this. And I use it PCF soft shadows as the shadows type. These give a softer and more realistic shadows. And the other one, this line, ACES fine tone mapping is a tone mapping algorithm used in Hollywood films. It adds a cinematic feels of the sign. And here, line 25. Then the skin and camera are set up. I added exponentially dense fog with fog exp2. The distance walls gradually become darker, and which supports the atmosphere of tensions actually. And the game loop works like this. A request animation frame triggers each frame, and dt, that is the data time, is calculated. And this is very critical. All calculations are done using dt so that the game runs at the same speeds. And I'm multiplying it by that. And I have limited it to a maximum of 0.05 seconds. And this is important. Otherwise, when the browser tab goes into the background, huge DT values will appear and physics will explode. And the other file, world.js, the world builder class programmatically builds the entire level, and this and these lines The basic idea is I wrote a helper function called box. These functions add a box geometry plus mesh standards material and the mesh then triple to the size and sets the shadow settings. All walls, floors, ceilings, and columns are created with the single function actually. And line 8 here. And the material palette is defined at the beginning. A floor, wall, ceiling, concentrated metal, glow, and the other one. I gathered these into a center objects. When I want to change the color, I change it from a one place. And the other line here, I set up the AABB, that is mean an axis elegant bounding box. A system for collision detection. Mean and max vectors are calculated for each wall, and these are added the colliders list. And the player is checked with this list in every frame. And survivors are placed on the signs as small glowing meshes. Each has active state and position. And the other one file player.js. And this line. And player controller manages the first person perspective. I use a 3D.js built-in pointer lock controls. This library captures mouse input, rotates the camera, and handles all the low-level works. And movement works like this. I create a direction vector from the wedged case, rotate it with the camera's rotation, add the velocity, and update the position. On line 27, if shift is held down of splitting, I increase the velocity from 5.5 to 9. And the other one, this. The flashlight is an interesting detail. I added spotlight directly to the camera. In 3D.js, when one object is a child for another, it moves with it. I also connected the target object to the camera, and from the camera, I placed the unit in front, so there is always light in my line of sight. The other one for this file here. The resolve walls, this function method handles wall collisions. For each AABB box, I calculate the player's closest point to the dead box. And if that distance is smaller than the player's radius, I push it back in the overlap direction. Actually, this function for this reason. And the other 5 physics system points. Yes. And the physics systems is at the heart of the earthquake simulation. A general simulation. When a trigger earthquake is called, the intensity and duration and adjusted then 1 or 2 aftershocks and are added the quick. In the update method, this method I generate camera shake with a sine function, a p wave, a longitudinal wave, and fast horizontal vibrations, and c wave, a transfer wave, slower but deeper tremors when I overlay the two with different frequency and amplitudes. It creates a realistic earthquake sensation. I show P wave like this. P wave function, and the other one C wave this. And there is a simple physics simulation for the debris pieces. I keep velocity and angular velocity vectors for each match. In each frame, the vectors are applied at the position and rotation. Gravity pulls the velocity down. The bounces decrease upon impact, damping, and the piece stops. And the other five, a gas system point GS. The gas system is directly related to the physics and simulation topics of the course. I built particle system using 3D points. Hundreds of particles are drawn simultaneously of the GPU. And line this position, color, and size data are stored in float arrays with buffer geometry, which are very lightweight structure. And the magnitude of the velocity is random, but selected according to specifically probability distribution. And the other line, important line here, as earthquake intensity increases, leak rate increases, the shaking puts strain on the pipes, and if the gas concentration exceeds 0.8, a large explosion is triggered. The camera crashes and the game ends. And I want to explain AI usage projects. I want to talk about how I developed the project because that's the main theme of the course. I started by decreasing each system to the AI separately. For example, for physics systems, I said write an earthquake physics system using 3D points. GS have P wave and C wave simulations, a simple physics loops for debris fragments, and the aftershock cube. The AI gave me a blueprint. I ran it, explained the users' issues and to the AI, and we fixed them together. And similarly, for gas system, I said write a gas particle system inspired by the Boltzmann velocity distribution. I directly added the physics concept, and we covered in this course to my prompt. Why did I do? I designed how each system would communicate with each other. I connected the system in main point jets. Gas systems receives the earthquake intensity, and physics systems triggers particle effects, and player control is affected by both systems. I wrote the integration part myself because I knew the global architecture better than AI, and I didn't blindly accept the code and AI generated. I read and understood every function, remote unnecessary part, and fixes performance issues. Let me show you the game live. Terminal open and npm run dev command right, and click the link. And this is our game. And there is the three cards on the start screen: a dynamic physics, a gas simulations, and resource missions. there is a three main mechanism of the game. And click the begin missions, and then pointer log is activated. And HUD opens, health and oxygen's bars are the bottom left. Uh, let's start. Yes. Health and oxygen bar in bottom left, and dynamic indicator is in the bottom right, and Hulk with the dash look like with mouse. I can run the flashlight on the with the FK like this. It is necessary in the dark rooms. Okay, let's start the game. Where is the person? First one, first person is here. Okay, let's save them. Second one is escaped. Arcade is wrong. Earthquake starts. Where's the other person? Yeah. Hmm. Okay, we are go to the exit. Thank you for listening.